Welcome to this explainer. Today, we're diving into a decades-old, absolute roller coaster of a mystery. We're going to investigate whether NASA actually discovered alien microbes living on Mars way back in 1976. So, let's jump right into the core question that triggered a massive scientific controversy, one that's literally still raging inside NASA to this very day. Did we actually find life, or was it just some giant chemical illusion? Well, we're going to break down exactly what happened, step by step, and look at why scientists came to such wildly different conclusions.
Starting with Section 1, the 1976 Mars Mystery. High stakes on the red planet. To really wrap our heads around this cold case, we've got to rewind to the post-Apollo era. You know, the moon landings were wrapping up, and the end of the Cold War rivalry brought these severe budget cuts that forced NASA into a major pivot. Instead of massive manned missions, they redirected their focus toward two robotic landers called Viking. It was an incredibly rapid timeline. We go from those post-Apollo budget constraints to 1971 when Mariner 9 mapped this barren but clearly water-scarred Martian surface, all the way to 1976 when Viking 1 and 2 safely touched down on the red planet.
Now get a load of this number. $600 million. For the 1970s, that was an astronomical price tag. The twin Viking missions were incredibly expensive, and the biological test units alone cost half that amount. $300 million just to search for life. What that meant in practical terms was that NASA absolutely could not afford to get the science wrong. The pressure to deliver definitive answers was just immense.
And to kind of ground us in the technology of the era, the landers miraculously sent back images of jagged volcanic rock and desert sand using a process that worked exactly like a vintage 1970s fax machine. It literally scanned thin vertical lines and converted light to frequencies. And what those rudimentary images confirmed was exactly what Mariner 9 had hinted at. It was a barren desert, sure, but a landscape deeply scarred by ancient river deltas. Water had clearly flowed there in the deep past, which meant potential life had plenty of opportunity to adapt to a change in climate.
Moving on to Section 2, testing for Martian microbes, hunting for the byproducts of life.
Safely on the ground at Chryses Planitia and Utopia Planitia, Viking's robotic arm reached out, scooped up some dirt, and dropped it into an incredible onboard mini laboratory. This lab ran 3 biological eyewitness tests. First, the gas exchange experiment added water and dissolved nutrients to look for metabolic byproducts like carbon dioxide or oxygen. Basically, if microbes are eating, they're going to release gas. The second step, pyrolytic release, exposed the sample to UV light and carbon dioxide to hunt for traces of photosynthesis. That actually yielded a slight positive signal. But it was the third test, belabeled release, that was the highly precise ultimate test. For this one, they added radioactive nutrients directly to the soil.
And here is the absolute jaw-dropper. That final labeled release experiment returned a definitive positive. When exposed to the radioactive food, the soil sample released radioactive gas. This essentially screamed that alien microbes were currently living, eating, and producing waste right there in the Martian dirt. In any normal circumstance, this result meant one thing: aliens confirmed.
Which brings us to Section 3, the conflicting chemical twist, the search for the building blocks.
Okay, so just as the champagne was about to pop over at NASA, the Viking landers ran a completely different forensic chemical test using an instrument called the gas chromatograph mass spectrometer. But what exactly was this chemical test hunting for? Well, it was looking for organic molecules. We're talking about combinations of hydrogen and carbon atoms, specifically long chains, that form the essential chemical building blocks of all biological life. You absolutely must have these structures for life to exist at all.
And boom. Here is the massive contradiction that really anchors our whole explainer today. On one hand, you have the labeled release test flashing a strong positive, clearly detecting the biological byproducts of living microbes. But on the other hand, the mass spectrometer heated the soil sample to 500 degrees Celsius to vaporize it and found absolutely zero organics. So how on Earth, or I guess how on Mars, could Viking detect the active metabolic waste of living microbes in one test, but find literally none of the chemical building blocks required to make them in the other? This huge conflict is exactly why scientists at the time reached completely different conclusions about what they were actually seeing.
All right, Section 4, NASA's strict final verdict, the missing middle.
Faced with this insane scientific cognitive dissonance, NASA had to make a really tough, incredibly strict call regarding the monumental discovery of alien life. Because let's face it, declaring life would profoundly alter humanity's place in the universe. So NASA employed a super strict set of parameters. To prove life, you need the foundation, which is the organics, and you need the positive biological result, the microbial byproducts. If you have both ends, the missing middle absolutely must be alien microorganisms. But because they didn't find that foundation of organics, NASA rigidly declared that the biological positives had to be officially ruled as inconclusive. They allowed zero room for middle ground.
But, the brilliant mind who actually designed that positive labeled release experiment completely disagreed with NASA's dismissal. Dr. Gilbert Levin took his conviction that he had found life to his grave. He was absolutely certain his instrument detected biology, and he firmly believed the failure to find organics was just an issue with the mass spectrometer itself, not a lack of life on Mars.
Fast forward to Section 5. Curiosity reopens the case, overturning the Viking baseline.
So, over the next 5 decades, NASA sends 5 more landers to Mars. But strangely, they never even attempt to replicate Dr. Levin's labeled release experiment. That is, until a modern detective showed up to double-check the chemistry. The Curiosity rover landed and completely destroyed Viking's baseline by finding exactly what the 1976 lander failed to detect. In 2014, it found chlorobenzene preserved in Martian rock. In 2018, it discovered organic compounds in mudstone. And remarkably, just in 2025, Curiosity identified long-chain hydrocarbons, specifically fatty acid structures.
What Curiosity actually found is basically a primordial diet sitting right there on Mars. We're looking at hydrocarbons, which are carbohydrates, and fatty acid structures, which act as fat. Literally, just add a little protein to those organic compounds, and you have a perfectly balanced diet for a living organism. Curiosity found the exact primordial soup ingredients that jump-started organic life right here on Earth. So here's the staggering takeaway from all this. Viking's initial conclusion of a chemically dead Mars? It was flat out wrong. And think about this. If NASA had known in 1976 that organic building blocks actually did exist in the Martian soil, the strict parameters of their own rule would have been met. The Viking biological experiments would have resulted in an official declaration of life. NASA's primary reason to dismiss the positive biological tests has completely vanished.
Which brings us to the end of our explainer with a massive, lingering question. What does this mean for us? And should we start looking harder? Since the chemical building blocks are definitely there, and the biological signals were undeniably there in 1976, is it time we go back and finally finish the job? Let that sink in as you consider the very real possibility that our textbook understanding of a lifeless Mars might just need a major rewrite. Thanks so much for joining me on this explainer, and keep asking those big questions.